Now we will continue our discussion regarding the first law of thermodynamics. Now we will consider the specific heat denoted by C, and considering for constant volume process, we have this CV, and for the constant pressure we have Cp. Now, the definition of this is it is the heat required per unit mass to raise the temperature of the substance by 1 degree. So it is the heat required per unit mass. To raise the temperature of the substance by 1 degree. Okay, so considering here the CV, we have that one. In our previous discussion, the first law, we have this formula here, the inexact differential of Q. This is du plus inexact differential of U. Since W is PdV, and we have a constant pressure, we have we have constant volume rather, we have the work is equal to 0. And now our CV, we can write this one as CV is equal to 1 over m, this is du over dt, considering a constant volume process. So this is 1 over m. You can write that as partial of U with respect to temperature, where we have that CV partial of U with respect to temperature. This is small letter u, considering constant volume process. Okay, so for Cp here, considering we have the constant pressure process, this is isobaric. So back to our formula, the first law. So we have an exact differential of Q, that is du plus this one W. So since this exact differential of W, this is P dV. Okay, so we have here an exact differential of Q, this is du plus PdV. Okay, and in our previous discussions we have this enthalpy here, that enthalpy is U plus PdV, and we going to differentiate it, this one. I'm going to take the derivative of dh, this is du plus P dV plus V dP. And since this is constant pressure, this dP here is 0. Okay, so the exact differential of Q is equivalent to this is equivalent to dH. Okay, so now So our Cp, therefore we have our Cp is 1 over m, and this is dH over dt, considering a constant pressure, or this is 1 over m, this is 1 the partial of t. So here, considering this is per unit mass, so this one. Okay, so we have that formula for our specific heat, considering the specific volume, or specific heat for constant volume, and the specific heat for constant process. Okay, let's now proceed on the ideal gas, wherein we have the equation of state. Equation of state with VV is equivalent to RT in here. So in the ideal gas we have here, so the specific or the internal energy here, it is a function of temperature, and so is the enthalpy. This is also a function of temperature. So U and H are dependent on temperature only. So we can write CV here is an exact differential of U with respect to temperature, considering constant volume process. So we have du here is CV dt, and we have this one u2 minus u1, this is CV t2 minus u1, considering the state 1 as an initial state and state 2 as our final state. And then we have two states here. So also we have the dH is equivalent to Cp dt, and this is H2 minus H1 equals Cp T2 minus T1, and H2 minus H1 is mass times Cp T2 minus T1. Okay, so here we have H this is equivalent to U plus PV, and this is H U plus RT based on the equation of state. So when we take the derivative of H, dH is equivalent to with respect to temperature, because this is a function of temperature, so this is du over dt plus r dt over dt. Okay, and this is Cpo, this is Cvo plus r, so our r is equivalent to Cpo minus Cvo. Okay, so considering the number of molecules, or in molal, we have R bar is equal to Cpo bar minus Cvo bar. Okay, if we have here the molal basis, and considering the number of molecules for a specific gas. Okay, so that's all, and thank you for watching.